Hi, this is Osvalin Bhartia, and we are here at LF Energy Summit in Paris. And today we have with us Zamarreño, member of Technical Steering Committee of PowSyBl and product developer at Grupo AIA. And before we start the interview, we are talking about the origin of the project. So let's start there. Talk a bit about what is PowSyBl, how it started.
We can trace back its origins to an European-funded project that was called iTesla many years ago, where we tried to perform security analysis for the European continental synchronous area. For that, we needed to develop a set of modules that were flexible enough to handle different analysis environments and scenarios, and also of industrial strength. That they were one of the key elements was performance at that time, because we had to analyze big networks like the whole European Union electric network. So with that ideas in mind, it was the first approach to start that project. After a few years of development, PowSyBl was entered under the LF Energy umbrella and is now part of the ecosystem.
Talk a bit about your company's involvement, which is Grupo AIA, with the project.
We were partners at that time in the iTesla project, and for the RTE, the French TSO was the leader of the project, and we have continued. We started our collaboration at that moment, and we have continued collaborating with them and participating, in particular, in the PowSyBl project since that time. Nowadays, we are extending even our collaboration. We have a collaboration also with the R&D department, starting new projects. We are proud of having become a reference provider for RTE in some parts of their developments.
Can you also talk about the role of PowSyBl project in today's world, where I asked this question to most of the folks from your ecosystem, is that the way we consume electricity is changing.
It's changing, yeah. And the way that we consume and produce electricity is changing, and that has a big impact on how the electricity is moved around. There are big restrictions on how the electric energy can move. It does not move freely, or it does not follow the paths that we want. It follows the paths that the laws of the physics state. So with more complex ways of producing and consuming energy comes more difficulty and more flexibility. We have now more flexibility in the consumption and production of energy, but that brings also complexity. So there are new needs for analysis, new scenarios that must be prepared, that must be considered, new things that even we cannot plan ahead in these days. There are changes that will happen that we cannot forecast yet. So it is important, we believe that it is important to build a set of tools that bring to the potential agents participating in that market, in the electric transport and distribution market, that allow these agents to first model, and then analyze, simulate the behavior of the network that they want to create or that they are operating. So there's no a single application nowadays, and not a single way to a single problem to solve, or the traditional problems that we were solving could be expanded and extended with new ways of new constraints, new restrictions. So we will have to adapt, and we are going to adapt. So what we envision is to provide a set of building blocks that could be used by any agent to build their own applications and to solve their own challenges. So we try to provide a library of components that can be easily integrated together, and that from the analysis point of view have industrial capabilities. They are performant, they are reliable, so you can trust the results that comes from their simulation. So this is more or less the context in what we are building and delivering our software.
Since it's an LF Energy project now, what kind of community is there around this project? Who is involved with the project?
We have a strong base of development from RTE itself. That was the corporation that created this software internally with their own resources and decided to open it to the community. But we have collaborations from different companies like mine. We are participating in it because we consider that it's a very interesting initiative, a needed initiative in the market. And there are already commercial companies that are using our product to offer services on top of it. For example, Artelis, that is a software company in France, is using our product, is using PowSyBl to deliver services for the regional security coordinators in Europe, for 2 regional security coordinations in Europe. So they will use, they are building the platform, they are delivering the final solution, but they will use PowSyBl and its components to perform a security analysis on a common grid model of the European Union.
Since you already shared some use cases, which means that a project is already, of course, it was European Union sponsored project, so it's already in the production stage. But talk about, when we look at from project's point of view, what is the state of the project? What are the next things that you're working on this project?
There are many things that we are trying to develop. For example, we want to provide strong support for a standard data exchange through the THEME CGMS standards, but we also want to support multiple industrial standards, de facto standards that are in the market. We have import and export capabilities for PSSE, for MatPower, for UCT, other formats that are usually used by the electric companies and where they could have their data. So we can provide an environment where you just drop your data and it is available for analysis. Another interesting thing that we think that we could provide is further optimization and analysis function. We are integrating a remedial action optimizer that was also an internal development in RTE, but it could be useful in many different situations where you have a problem or you want to keep your network under a certain constrained operation, and this tool that will be integrated is being integrated, in fact, inside PowSyBl, will help you suggesting which actions you must perform on your network to keep it within a certain range of operation constraints.
Can you also talk about some of the exciting use cases of PowSyBl project?
One of them could be, for example, it has been recently adopted by ThemeSpy product, that is a reference tool sponsored or adopted or labeled as a reference tool by the ENSOE, the community of TSOs in Europe. It is called ThemeSpy, and they have integrated our PowSyBl modules to offer power flow calculation to their own users. So it's a situation where a commercial product has adopted one kernel that has been made by the community, that is open source, to deliver a product with a new functionality. Another interesting use case, maybe, it's we have some users that are trying to use our package, our building blocks, to explore the interaction between TSO and DSO, between the transmission, the part of the network and the distribution part of the network. And there are interesting things to solve in this area, like that we have already started to think about, like or to develop like asymmetrical load flow calculations. And so these are areas where we can expand our support for analysis in general.
One more thing that I want to talk to you about, that these days we talk a lot about, and I mean, when I used to talk to Shuli also, we used to talk a lot about climate change, the bigger problem that we are trying to solve. When I talk to a lot of these projects, they're like, no, we are trying to solve this specific one, but the fact is that it is actually helping solve the much bigger problem as well. Every bit matters, every drop in the ocean that helps. So talk a bit about what role you see projects like PowSyBl can play in this.
Yeah, I think that electricity is a commodity that we need nowadays to keep the world running, and it could complete electrification of all our energy needs could help reduce the impact of climate change. If we generate electricity with the proper resources, renewable resources, and all our needs of energy are covered using electricity, then we could make a huge impact on the positive impact on the climate change. But having everything electrified means lots of complexities. We need to change our infrastructures. We need to change to new ways probably of distributing and engaging with electricity. So we need tools that help us to progress towards this scenario. So we saw ourselves like contributing in that small amount. We provide tools that will help the humanity to proceed further with the electrification, and that would be benefits in that area.
Luma, thank you so much for sitting with me, talk about this project, the origin of the story, and where it's heading. Thanks for all those insights, and I would love to chat with you again whenever there is an update on the project.
Thank you for welcoming me and your help in the discussion. Thank you.